Hi, I'm Peter Lawrence. Getting answers to questions about, say, urban design codes and other regulations can be tough. There are hundreds of pages in multiple documents to sift through. Many hours can be lost. Finding the correct answer can be hit or miss. Our solution is Place Copilot, powered by Dedoctive, a tool that allows users to get trustworthy answers to such questions from multiple documents in seconds. Most organizations have large quantities of information in the form of documents, spreadsheet, database, emails, and so on. These contain a significant amount of knowledge, but is largely inaccessible to the average user, mostly because of the sheer volume. Dedoctive solves these problems by automatically creating a comprehensive knowledge model of the document library. Users can then ask their questions. Dedoctive discovers from this knowledge model the relevant facts. Dedoctive then assembles the answer using an LLM from these and only these facts. Then it provides the provenance of the answer in the form of cross-references back to the source of knowledge, thus providing trust in the answer. It also provides a knowledge map of the path between the question, answer, and knowledge facts. However, it's far better to see it in action to get an idea of what I'm really talking about. I would like to demonstrate to you Place Copilot powered by Dedoctive using Surrey's Healthy Street transport plans together with multiple Department of Transport national guidance documents. Place Copilot is an easy to use chat interface that can be profiled to match the user's need, from casual user looking for quick, brief answers to a competent user seeking detailed descriptions of the requirements. I'll assume that we're looking for detailed technical answers to our questions. Click to enter. So, like all good cooking shows, we have prepared some questions. Let us suppose we are a developer looking to understand the updated requirements for bicycle parking. Simply enter the question and wait for the answers. As you can see, we have a detailed answers here, grouped into various areas, but interestingly enough, the answers include the source of the facts in each of the cases. For example, here we're referring to a national guideline. If we want to follow through to find out greater details and find the actual source of authoritative information, we can click on that document and it will bring up that page in that material that was used. Furthermore, we could click here and see where it comes from, in this case, from the Healthy Streets. Now, one thing that we can see that these links are not just referring to text within the source documents, but diagrams, pictures, tables, etc. Dedoctive, when indexing these documents, also interprets such elements and adds them, allowing us to query information described in images rather than just written out as text. We also look at this answer. This text has been assimilated from all of these facts, but we might ask ourselves the question is, how has it assembled this answer? Why did it assemble it in that way? And we have the opportunity, what is to call explore the response. When we explore the response, we assemble a knowledge map, and that knowledge map describes how the answer is assembled from individual fragments of information, and those fragments of information are followed through to other fragments or diagrams within the text. Thus, we get a full detailed description. Finally, we might want to consider some follow-up questions. For example, what about the different varieties of cycle? So let's ask that follow-up question. And we can see the different cycle types that are referred to in various documents, and we can see cargo, solo, tricycles, etc. What other things, as a typical user, we've got this answer. What do we mean by high quality design that is referred to in the original answer? And we can include that in our follow-up questions. So we can see the different aspects that are considered. Again, all of these aspects are drawn from different parts of the document, but they've all been assembled together in a single place. Do we find these answers overwhelming? Maybe we do. Let's start a new chat, but this time let's modify the profile. I'm going to ask for simple, brief response. And just to prove it's different, I'm going to ask the same question. This time, perhaps I'm taking the perspective of a casual user, just interested. You know, is the county meeting the requirements for bicycles? So let's ask that question and let's see the different type of response. I think you can immediately see that the response is much briefer and more direct, even though it's actually using a lot of the same information. And that's it. That's how Dedoctive, powering PlaceCopilot, is providing access to all of these excellent documents, but provide it in a very easy, quick format. Dedoctive has solved the problem of accessing the knowledge within an organization's vast quantities of documentation by automatically creating a comprehensive knowledge model of that library. Why is this different than other approaches? Traditional text searches do not solve this problem. Text search engines only find textual matches, not answers to questions. For example, if we ask the question, what specific design considerations for the corridor between Gatton Park and Longbridge, they will try to find a document or web page that most closely matches the words in our question. However, if no one has written a single document that contains both of these phrases, then the search will not answer the question. It might find pages with similar words, but it still not answer the question. Database searches require all the data to be converted to a structured form. This requires expensive and time-consuming extract, transform, load processes. Even after that ETL, questions will be confined to predefined queries written by experts. Database querying, especially ad hoc queries, is not easily available to the average user. Frankly, not a viable approach. What about AI? AI engines have been trained on a staggering amount of data, mostly documents drawn from the web. With this training, it will always provide an answer, but is it accurate, relevant, or is ChatGPT just trying to please you with an answer? We want answers to questions based on our own information with which public AI engines have probably not been trained. We could train our own large language model with our own information, but this is difficult for structured information and nearly impossible for unstructured text. Even with our own trained large language model, we cannot be certain it will use only the knowledge upon which we have trained it. It still might hallucinate or use other information. Dedoctive solves these problems by automatically creating a comprehensive knowledge model of the document library. Dedoctive does this by first performing a fine-grained detailed analysis of the domain's information, documents, spreadsheets, images, tables, etc., from which it creates a comprehensive knowledge model. This knowledge model combines indices of similar meaning, similar words, and relatedness. Users then want to ask their own questions. Dedoctive users can ask questions of this knowledge by using natural language. Dedoctive then refers to this model to assemble all the relevant facts. Relevance is deduced from similar meaning, semantics, similar words, lexical, and relatedness, graphical indices, to ensure that only pertinent knowledge facts are used. This ensures that irrelevant facts are not delivered to the large language model, because they will lead to it astray. Dedoctive then uses the power of the large language model to assemble the answers from these and only these relevant facts. However, many users lack trust in answers provided by black boxes. This has always been true, but has been exacerbated recently by fake news, AI hallucinations, and dubious data sources. Deductive adds provenance to each part of its answer, referencing to the source of the knowledge within the document collection, thus providing that trust. Users can easily follow these hyperlinks back to the source of the fact. Users will also want an explanation of how the answer is assembled from the source of knowledge. Deductive explains how the answer is assembled by providing a knowledge map. The knowledge map shows how the answer is assembled from fragments from within the model, how these facts are interconnected, and where those knowledge fragments are within the document collection. Deductive is very flexible. It can be applied to any situation where there are large quantities of documentation in the form of text, diagrams, tables, images, structured data. It's easy to deploy. The initial collection of information, sources, documents, diagrams, etc. is identified either as hyperlinks to their source or actual copies. This initial collection is then forensically analysed by Deductive to construct the deductive knowledge model. It is then ready to start delivering answers to questions. More information can be added and existing information can be removed to ensure that the collection reflects the complete domain of knowledge. Deductive has been applied to a wide range of knowledge collections: city master plans, telco knowledge bases, Historic England's guidelines, project execution contracts, guidelines for retrofitting buildings, the UK Care, Human Rights, Health and Safety and Equality Acts of Parliament. It could be building resident guidelines, national rail buildings, regional infrastructure development planning guidelines, city centre design guides. It could be your information. Thank you for allowing me to present Place Copilot powered by Deductive to you. I hope you found it interesting.